Okay. So the next thing that would be interesting to do is work more on sequences. I'm going to have a new file. I'm going to call it sequences.py. And again, let's look at something that we already have, but we want to do our own version just to learn how to code. Okay, so if I have a list, all right, I can say min L, and I get the minimum value. All right, so what if this min didn't exist? Can we write our own? So I'm going to say def. I'm going to call it my min. All right, and we're going to take in a list L. So it turns out that it doesn't make sense to have a minimum for the empty list. All right, so if the list is empty, and I don't need these brackets, I'm in a different language. If I do that, we're going to return none. We can return this value, which says, well, there's no such thing as the minimum of a empty list. Else, elif. Okay, if, right, the len of L is 1, then we have a single element, and the minimum is exactly that element. Return L0. Okay, else. So what else could we do? So let's say now we have a long list. We have at least 2 elements.
Can we compare the first two?
Right, so let's say we do that. What?
Take the smallest value, and I don't usually compare it to the third.
Again?
So we take the first two values, we see which one is the smallest, and we take that smallest value, we compare it to the fourth. To the third, sorry. Then we go on and take the third.
Right. So, but you have to think of it as, you know, a continuous process. Right? So what we know at this point is that the list has at least 2 elements. We already handled the case for 0. We also handled the case for 1. So when we reach here, it's a list of at least 2 elements, right? So it makes sense what you say, right? So I can say if L0 less than L1. What then? Louder? Well, I haven't looked at L3. What if L3 is smaller? So definitely L1 is not a minimum. I can remove it from the list, right? So I could say return L0 plus, sorry, min L0 plus L2 onwards. Right? So by writing this, this is the same list as L, except that the first element ranked 1, is removed. Yeah? Else return, right? So if L0 is not smaller than L1, I know that L0 is not the minimum, right? So I can return, actually this is my min L from 1 onwards. Yeah? And here we're going to write the same. So definitely this list is shorter by 1 from the original list. The same with this one, it's shorter by 1 from the original list. Right? So at every time I call my min, it's going to be with a shorter list. At some point, that list is going to have size 1. When it has size 1, I'm just going to return that number. Yeah? So I'm going to reuse this. And I'm going to say the min of list L is my min L. Okay, so let's see if this works. And you see that the result is correct. Yeah, so this is always how we reason. So we're trying to reduce the problem, solve the same problem for a smaller size. Yeah, until we get to something that is very easy to solve, like a list containing a single element. Now, another interesting problem would be to sort the list. All right, so sorry, I need to do Python here. All right, so you see we have sorted here, this sorted. So if I take the list L, and now I say sorted L, I would get this list in sorted order. So again, we have already a function that does that. But let's say we didn't. Okay, how would we write a function that does the same thing? So I'm going to say def sort L. So obviously if we have an empty list, the sorted version of that is also the empty list, right? If equals 0, return L. So if I have the empty list, I return the same thing. Else. Now, one interesting thing, excuse me. So now one interesting thing is that we can remove elements from a list. So if I do dir L, I will see that I have this remove. So I can say help L.remove. Remove first occurrence of value, right? So, for instance, here, this is the first occurrence of 7. Yes? So if I say L.remove 7, L doesn't have that occurrence of 7 anymore, right? So, what could you do, right? So, what in the sorting of L, which one would be the first element? The smallest, right? So we already know how to compute the smallest. So we say that m equals my min L, right? And then return, and I know for sure that the first element of the sorted list has to be m. What's the reminder? Louder?
We remove n from the original.
Yes, we remove n, right? So we're going to sort L dot remove m. Yeah, and this is it. So if I want to sort increasingly, the first element should be the smallest. So I find the smallest, and then I put it right here in my result, right? The rest should be whatever is left by removing m, I will sort that recursively, and I should get same thing. So let's do the same. All right. And we're going to say print the list L when sorted, it becomes okay. We exit from here, we run Python sequences. All right, and we see that we get the sorted version of the list. Yes? All right. So the next thing I would like to try is to, first of all, get your computer set up for the game. So since I don't remember everything by heart, I am going to go to last installment of the course, which should be here. Right, so we want to import this module called Pygame. All right. In order to do that, you have to be at the command line prompt. And there is a command called pip. Let me find the right thing. Pip. Is it pip? All right, so for me, it's already installed because I did it in the other half of the semester. You should be able to do the same thing. So try running from your command lines. Pip. All right, so whatever command you use for Python 3, repeat that, but just remove the word Python and replace it by pip, and then say install Pygame. All right, and see if that works for you. So on the Mac, it's very easy. On Windows, yeah, but not here. Here. can I see pip3? Can you see pip3? So repeat the command, just go and edit. Repeat. Up arrow. And then go and add a 3. No. Yeah. Oh, cool. Okay, how do you run Python? No, when you run Python, how do you do it?
Rename.
You never do?
Yeah, you roll over slide.
Okay. Well, just trying to follow.
That's what I use.
Yeah, 3 should be in one word. But let's see if this works. Oh, you're inside. This one.
Python.
No, so yeah, Python is, but it's not. Is it tools? I should take these things down. How do you do it on Windows? So, pip Windows. All right, so ooh. Yes, and bring it in the folder, in the course folder. Looks quite ugly. I thought pip would come with pre-installed with Windows. Okay, this is easier. Actually, it's not necessarily easier because you won't have curl. Python and OS. All right, so try this. Use Python3, your Python command, and try -m pip install -u pip. And let's hope the package is there. This should work on Mac as well, actually.
I should have an invalid syntax.
So you see, if I go here and say this, no module name named pip. It's there, so why not? All right, so it seems that the easiest way to do it is going to this site, Liquid Web, getting this get pip.py. So you say save link as. Here you pick the same folder where you have currently your files. So that's for Windows. And then you run this, Python2. Yeah. Oh, can I see whether you downloaded?
Yes.
Yes. So is it there? Can you do it there? Okay, wonderful. Just that you don't have the PY. It shouldn't matter though. I'm not sure where are you. You're not in the right place. Is this the place where you have the files?
You mean files for Python?
Yeah.
Oh, no.
Can you go there?
Yeah.
Okay. Just open a new. No, so let's delete this. Can you go back to where your files are? Which process is this? I don't know what to close this.
Usually I close up Python.
No, you might need to reboot. I don't know what's. incredible. I'm afraid you have to reboot. I don't have any quick fix for this. For rebooting, all right, so we're going to do another attempt. So I'm going to try very quickly to demonstrate what it means to be in a graphics window. All right, so so we're going to open, here we're going to open a file called game. All right, and we're going to say import Pygame. All right, and I'm going to add these few lines, which don't appear very well. So actually, I don't. I'm going to make this slightly smaller. And I'm going to start explaining. All right, so the graphics system is on every computer is different. On every operating system is slightly different. All right, and always needs to be initialized. So one thing that we need to do, unlike what we experienced before, is we need to open a window. All right, we need to get to the point of opening a window. All right, we're relying on a library, which is Pygame. All right, we want to open a window of certain size. So you are probably guessing now that the width and the height of the window are going to be 800 and 600 pixels, right? We're going to call an initialization function. All this is magic. It's recommended in the documentation. We just do it as is, right? We're going to set a repetition rate for keys that are continuously pressed. So if I keep down my finger on the key, how often, how frequently is that key going to keep appearing to be pressed? All right, and there's a matter of getting a screen depth. The screen depth is the number of colors, and we want 32 bits of color. And we're going to give a name to the window, and we're going to see the name of the window as being asteroids. And we're going to initialize a clock, and we're going to find out a little bit more what this clock is about in a minute. I'm going to go to the end of the file, and I'm going to perform an update. And so I'm going to copy this as well. We have pretty much what we need to so how does animation work? So this is about animation, right? It's a game, but the basic technique of having the game played on the screen is animation. So animation performs the display of a sequence of frames. The frames are static images, right? So we draw a scene, we display it in front of the user for about 1/30th of a second, right? As this is being displayed, we build the next image, and then at some point we're going to do this update, and the new frame is going to replace the old frame on the screen, right? And then because the new frame is slightly different from the previous one, you get the notion of movement. And if we're going to do it about 1/30th of a second, we're going to display about 30 images per second, and which is standard television, and this is how it's going to work. Now, how long do we do this? You see a while true. While true means that this is infinite, right? It's not really infinite, because inside here we are reading the keyboard. We are trying to find out what event did we receive from the entire computer, right? So you can have mouse events, can have keyboard events, we can have a USB plug being plugged in, we can have a network packet arriving, right? All these events can be read. And we will work mainly with the keyboard, and we want that whenever we press on the this marker for closing the window, which is this one, we want the window to close. Or if we press a key down and that key is the escape key, right, we also want to quit. We have to quit in two steps. One is we shut down the game library, and then we exit the program, right? So currently we're not drawing anything. So if I if I run this program, I'm going to see an empty window opening up, right? And there's nothing in there. But when I press escape, I'm going to quit. What is this about? Well, we don't want more than 30 frames per second, because we might overheat the CPU, we might slow down the computer, right? So this guy, if this loop executes very fast, this guy will introduce a delay so that this loop doesn't execute more than 30 times a second. And it's smart enough to figure out how long the delay should be, so that, right, each time around the loop takes about 1/30th of a second. You can replace this number to whatever you like. The larger the number, the more CPU you're going to consume. The more likely is you're going to start hearing the fan, going up. And all right, so let's run this program and convince ourselves that we have everything we need. And we already have a missing rect. So rect is a rectangle, and it has a definition somewhere. And we missed these lines, right? So it's not enough to just import Pygame. We need to import stuff from inside Pygame. So pygame.locals from import star, from pygame.locals, sorry, import star, from pygame.constants import quit. And we see the empty window, we see the asteroids, and as I press quit, and I press escape, I can't press escape. If I press escape, I stop the recording. Anyway, if I press here, it will shut down. Now, another thing that we need to do is this sys is not imported, so let's import that one as well. Import sys. Okay, this one, there's a K there that I don't know where it's coming from, and I think that's wrong. We just had it. Okay, so okay, if I press here, okay, escape. Now I can press escape. So you can see how escape turns off the program. If I hide this part, let's just see what happens if we don't do this. So I'm going to comment it out. Yeah, and I'm going to run the program again. Right, and you see it completely differently. And now I'm pressing here, and it doesn't close at all. Right, so it is essential to read the stuff from the keyboard. I can still go into this window and press Ctrl+C, which will forcefully stop it. Right, which is something that we generally don't. We want to avoid. We want to avoid forceful stops. All right, so let's try to draw. Do I have a circle here? There we go. This is how we draw a circle. So let's try to draw a circle and have a bouncy ball, right? So let's first just draw a circle. So notice that we have to use the screen, which is what we have defined here. We have to define a color. A color, we said that it has 32 bits, but most computers, they lie to you when they say they have 32 bits of color. They actually have only 24. There's three main colors, red, green, and blue, all right? And all the other colors are produced out of these. And how do we create colors? We go on red, green, and blue and vary the intensities. The intensities can go from 0 to 255. So here I will produce a triple with three numbers between 0 and 255, right? So for instance, something that is around 200, 0, and 0 would be red. Not the brightest red. The brightest red would be 255 here, but this would be a reddish color, right? I need a position. So I'm going to initially have the position of right in the middle of the screen. So I'm going to have 400 and 300. Remember, the size of the screen is 800 and 600. And I need a radius, and I'm going to use a radius of 50. Okay, and let's see what comes out. All right, so we have a circle. It's a full circle. It's red in color, right? And it doesn't do anything for the time being. So let's try to bounce this around the screen. You surely have seen a bouncy ball before, right, in the screen. So let's try to do that. How do we do that? We have the ball running at an angle of 45 degrees, and it reflects on the boundaries of the window, right? So we're going to start with a position. So outside of the while loop, I'm going to have a position equal to our initial position of 400 and 300, all right? And I'm going to have a velocity. So velocity is going to be again in two directions. So and the higher the velocity, the faster it's gonna go, right? So I'm gonna start with something like 5 and 5. I have no idea whether 5 and 5 is too high, too low. I could start at 1 and 1, but I don't want to start experimenting from that low. All right. So now, whenever the position reaches the boundary, we should have it reflected, right? So we're going to say, right, if pos 0, right, pos 0 would be this number, right, is less than 0, or pos 0 is greater than what we had there, 800, right? So pos 0 is the x coordinate, 800. I'm going to make the velocity and I'm going to be, because if I use tuples, I can't change, right? I'm just going to allow myself to change them. So we're going to make them lists of 2 elements. So if pos 0 less than 0 or pos 0 greater than 800, the velocity for x has to change direction, right? So I'm going to say velocity 0 is assigned minus velocity 0. Just change directions, right? And the same for pos 1 for y-axis. So pos 1 less than 0 on the vertical axis, we only have 600 pixels. And velocity 1 right? So then we're going to do pos equals, and I'm going to create a list here, pos 0 plus velocity 0, and pos 1 plus velocity 1. Yes? And then here, instead of 400 and 300, instead of a constant, I'm going to put pos, except that, right? Let's see what happens. So this is not going to work as we expect. Let's see what happens. All right, so you see the reflection. There's quite a few things. So the first thing we want to do is to remove the trails. So we want to clear the screen before displaying the next screen, all right? And that is done with something like with a clear. All right, so screen fill. This screen fill is going to fill the screen with the color indicated there. So before drawing anything, we're going to fill the screen with this color. And this color is, of course, black. It has 0 red, 0 green, 0 blue, so it's black. So if I run it now, notice that I have an animated ball that bounces, but it doesn't bounce well. Why? Because it has a size, and the reference point is the center. So we are reflecting the center and not the bound of the circle on the bound of the window. So in order to do that, right, we need to subtract the radius from the bounds. So I'm going to say if less than 0 plus 50, which is the radius, 800 minus 50. And here, 0 again plus 50, and 600 minus 50. And we're doing it this way because I could compute the numbers, but later we're going to parameterize. I don't want to use 50. I'm going to use the radius r, right? And we're going to Remember that. So now we have a nice bouncy ball. Yeah. So this sets the provides the setting for us starting to write a little game. I'm going to describe the game next time. You can research asteroids. This is a very well-known arcade game from the time when computers were about 1,000 times as slow, right? Slower than what they are today. And pretty much we couldn't do a lot back in these days. This kind of things were just ideal. So we're going to write a game that can be written in about 6 hours. Right, then you're going to have that experience. You're going to see a little bit of animation. You can research asteroids. The important thing, I'm going to upload, of course, this, is to try to set up your computers with Pygame, with this package. So it's very easy for Macs. For Windows, unfortunately, have a little bit more trouble. I'm going to research a solution for Windows machines and try to post that, so you can try to follow that. If I had a Windows machine, it would be a lot easier. Cool. This is it for tonight. Any questions? Okay, show me.